Welcome back to the second part of Pre-Calc Notes 9.3. The second part is going to deal with finding the sum of a finite geometric sequence. We had a formula like this for the sum of the finite arithmetic sequence in the previous section of notes. This section will have one for the geometric sequence. So it's important that you understand, first of all, how we are setting this up. And then really what I have in red here is how you use the formula. So it's important that you first understand that you're going from starting an n value of 1, so the first term of the sequence, to whichever term of the sequence you're going to. If there's 6 terms, it'd be 6. If there's 12 terms, it'd be 12. And then what you're doing is, the way that a geometric sequence is set up is that you have the a sub 1 here, so the first term, times the common ratio raised to the n minus 1. And then the way we use the formula is by taking the first term and multiplying it by this fraction. We're going to get 1 minus common ratio raised to the n power over 1 minus r. So this is how we use the formula. But again, it's important that you understand how to find your a sub 1 and your r values. So if I ask you to find the sum of 1 plus 3 plus 9 plus 27 plus 81 plus 243, you could very easily type this into the calculator and get your answer of 364 and be done. But I want to show you how you could do that by using this this formula. So I already know what my answer is, but again, I want to show you the formula so when we look at the rest of these, they'll become a lot easier to deal with. So the things I need to know to be able to use the formula, I need to know what the first term of the sequence is, and I need to know what r is. And I need to know how many terms are in the sequence. So I'm just pulling those from the formula, here, here, and here. So in this sequence, the first term is 1. Looks like there are 1, 2, 3, 4, 5, 6 terms. So my n value would be 6. And then finally, my r, the common ratio. What do you have to multiply 1 by to get 3? Well, you have to multiply by 3. If I multiply 3 by 3, do I get 9? Yep. Because really the sequence is this. That's the sequence. I put plus signs in the middle because that's what I want you to do. I want you to find the sum. So again, my ratio here is I'm multiplying each previous term by 3. Multiply 9 by 3, I get 27. 27 by 3, I get 81. 81 by 3, I get 243. So my common ratio is 3. So now let's plug it into the formula. So again, I'm using this formula here. A sub 1 is 1 times 1 minus 3 raised to the 6th power over 1 minus 3. So reducing this, I still have the 1 on the outside. This would be 1 minus 729. And this would be negative 2. And so this would be 1 times negative 728 divided by negative 2. And so that'd be 1 times 364. And I'd get 364. So again, I already knew that that was my answer because, like I said, when you have such a small sequence like this, you can go through and you can actually just add them all up to get the answer. But I wanted to show you how to do this by using the actual formula, because now we're going to be able to use the formula when we are given the sequence like this. So let's take a look at the next example. Okay, so I want you to give me the sum of the first 1 through 10 terms of this sequence without actually seeing the numbers listed out in the sequence so that you can add them up. So you've got to use the formula. So I'll write the formula down here again for us so we know what we're looking at. So the things that you need to know are a sub 1, r, and n. And remember, when I'm writing a geometric sequence like this 8 is my a sub 1, and this 1/4 is my r. Okay? And then I can find the number of terms in my problem by saying, well, 1 through 10, that gives me 10 numbers. So n is 10, a sub 1 is 8, and r, the common ratio, is 1/4. So it's important that you understand how to read this to be able to pull out the information that you need. You needed to know those 3 things, and you're given all of that. You just have to recognize that you're given that information. So if I plug in my numbers, 8 times 1 minus 1/4 raised to the 10th power, all then divided by 1 minus 1/4. So here's where we're going to want to get creative with our calculator. Let's plug into our calculator this 1 minus 1/4 raised to the 10th, get an answer there, and then divide that by 3/4. And I've already done that, and I'm getting 8 times 1.333332062. But I want to keep that exact value in my calculator. So when I times it by 10, now I can round it. And I get about 10 2/3 or 10.67. Oh. So 10.67 would be my answer. Okay, the next problem asks you to find the sum of the first, from 0 to 15, so the first 16 terms of the sequence that has 2 times 4/3 raised to the n power. Now here's what I want you to pay attention to. In our finite, and again I didn't stress that in the last problem, in our formula we're dealing with a finite sequence. So I know I have a clear starting and stopping point, n is 0, and the last n value would be 15, so that's 16 terms of my sequence. So again, you can only use this formula when it's a finite sequence. We'll deal with what we do when it's not finite in just a minute here. But I want you to recognize that our formula says that we should have our a sub 1 term here, and then this would be our r term, but then it has to have an n minus 1, and this has an n, and it has to start at an n of 1, and it has to start here. You know, this starts at a 0. So if you were to plug a 1 into here, and I do 1 minus 1, I get a exponent of 0. So when I use this formula here and I plug in a 0 here, I'm going to start this off with an n of raised to the 0 power, so it's going to be the same. So this says if it doesn't match with the formula, see what you need to do to make it work. Well, in this problem I don't have to do anything to make it work because it starts out at an n of 0. And normally it should start out at an n of 1 when you're using the summation formula. But because they've taken care of that issue by putting it in as an n here, so when I plug it in I get a 0, it'll still work for this formula. So let's go through and identify what we need. We need to know a sub 1, r, and n. So the first term of our sequence was 2, the common ratio is 4/3, and the n, the number of terms, from 0 to 15 is really 16, because we started at 0 and not at 1. So we'd have 0, then 1, then 2, then 3, then 4, then 5, all the way up to 15, so that would give us 16 total. So pay attention to that. Don't just assume that's 15. It would be if we started at 1. And now let's plug it into our formula. So I'm going to use this formula down here. A sub 1 would be 2, and then 1 minus 4/3 to the 16th power over 1 minus 4/3. Again, this is a matter for our calculator, so I invite you to pause the video, take the time to plug this all into the calculator. Again, get an answer in the numerator, divide that then by whatever 1 minus 4/3 is, so negative 1/3, and then times that by 2. I really do invite you to stop the video and try to get your answer here, to make sure that you're filling this out correctly and using your calculator correctly. Okay, so if you pause the video, you should have gotten, and tried it on your own, you should have gotten 592.65 as the sum of these terms. Okay, so the next one that we're going to take a look at now is the sum of an infinite geometric sequence. So you notice that in our previous one we started at 1 and we went to some n value. We had a clear stopping point. When it's an infinite sequence, it doesn't have a clear stopping point. It's going to go to infinity. So it's going to start at n and it's going to go up to infinity. So again, here's the way that the formula should be set up. A sub 1 times r raised to the n. Okay, because I got a 0 here, that's why it's not an n minus 1. And this is the actual formula that you use. So again, I put that in red so you can see that that's the formula. This is just letting you know how it should be set up. So the only things that you need to know to be able to use this formula, since you're not going to have a specific number of terms, so you don't need to know what n is, you need to know what a sub 1 and r are. So looking at this, the way that this is set up is that this would be my a sub 1, this would be my r value, so 4 and then 1/4. And because I'm going from 0 to infinity, so it's matching this, I don't have to change anything in the formula, I just plug it in now. A sub 1 is 4 over 1 minus r, so this would be 4 over 3/4. I can get rid of that by multiplying by the reciprocal. So I should get 16/3 as the answer to this. So again, for this problem, I'm not going to be able to actually, for two reasons. I don't have the actual sequence listed out, but I'm not going to be able to just add it up and go the first term plus the second term plus the third term plus the fourth term plus the fifth term to get my sum. And like I said, for two reasons, I don't have the sequence, and I also don't have a stopping point for the sequence. So how would I know when to stop? I don't, because it goes up to infinity. So using this formula here would let me know that I would have 16/3 as my sum when I plug it in. Again, when you're using these two formulas, pay attention to whether it's infinite or whether it's finite, like it has been in the previous section. If you have infinity here, you need to make sure you're using the infinite geometric sequence formula. Versus this one, where you have it being a finite geometric sequence, it has a clear starting and stopping point. We know what it's going to go to. It's not going to go to infinity. So again, make sure that you're using the finite versus the infinite one depending on which type of sequence you have. That's going to be key to being successful in this section.